then we start. All right, let's break a leg. Uh-huh. Y estamos en vivo. Muy buenas noches, amigos. Gracias por acompañarnos a la plática de hoy. En esta ocasión tenemos el enorme privilegio de platicar con uno de mis héroes personales, el físico y cosmólogo Sean Carroll, y para ayudarme a presentar distintas perspectivas en el tema del universo y el significado de la vida y otros temas de los que nos encanta hablar en este canal, me acompañan mis amigos Daniela, David, Manuel y Porfirio. Ustedes ya los conocen, son un grupo de científicos de Caltech, orgullosamente latinos, cada uno experto en sus disciplinas, y ya se darán cuenta por las preguntas que hagan. Bienvenidos, amigos, los voy a mostrar en este momento. Y por supuesto nos acompaña el invitado de honor, Sean Carroll. First of all, Sean, thank you so much for doing this. It is a great honor. And we have been reading this book of yours, the big picture, which well, I'm listening to your podcast, and I don't want to sound like a fan, but but we've been wondering if you could talk a little bit about like how do you see yourself? Because on the last talk we had, Porfirio said something about you that I truly agree, and it is that you might be the first philosopher who actually engages in the discourse through scientific method. Would you be in agreement with this statement?
Sadly, no, I would not be in agreement with that statement. I'm honored. Thank you very much. But it's an interesting thing. Let's turn the statement around a little bit. There are philosophers out there who are extremely highly educated in physics. There's plenty of people who are not plenty, but there's some people who are professors in philosophy departments, very well-respected philosophers, who have their PhD in physics, don't have any degrees in philosophy. And there are also some physicists out there who know quite a bit about philosophy. But I think that the impression that you're correctly pointing at is that these people are rare. There's not a lot of them, and they're not that well known. It's much more common to talk about or to pay attention to the scientists who disparage philosophy for not being interesting, or the philosophers who go on talking about the world without knowing what we have discovered about it scientifically. So I'm happy to announce that I think that the overlap or the intersection between these two fields is actually growing, even though it's still quite small.
So how do you get first involved into this? Like, since the beginning of your scientific career, you were interested in philosophical questions?
I've always been interested in understanding how the world works. And to give you a sort of medium length answer to that question, I can give you a longer one if you want. But I had never really discovered philosophy at all until I was an undergraduate. I went to Villanova University outside Philadelphia, and it was a Catholic school. I'm not Catholic myself, but Villanova was. And so they had this old school idea that they would have required courses. We had to take 3 semesters of philosophy, 3 semesters of religious studies, 3 semesters of history, all this stuff. So I was basically forced to take philosophy, and I loved it as soon as I first started with it. And in fact, I ended up taking more than I was required and getting a philosophy minor. And I did study at the time some philosophy of science, but it was mostly about, how theories are chosen, how science is done. It was really sort of diagnosing science rather than trying to understand the universe. And it wasn't until much later, it wasn't until I was a professor that I realized there's a whole community of philosophers who are doing what's called foundations of physics. And it's really physics. They're just doing physics, but it's the kind of physics you wouldn't be allowed to do in a physics department. So they do it in philosophy departments. And that's really the sweet spot for me. That's something I'm very happy with.
How does that work, physics through philosophy?
It works different ways for different people. I had David Albert on my podcast, for example. And, he told the story on the podcast of when he was a graduate student in a physics department. And he became interested while trying to understand quantum mechanics. He became interested in the measurement problem, which is very highly a focus of interest for people who do philosophy of physics. And he actually, there's no one there at his university who was interested in that, but he got hooked up with Yakir Aharonov, who's a very famous theoretical physicist. The Aharonov-Bohm effect is something you've heard of if you do physics for a living. And they actually, collaborated and wrote papers together on the foundations of quantum mechanics. And then his PhD thesis committee said, no, we will not let you count that as your thesis. And they forced him to write an extremely technical mathematical paper about the Borel summability of phi to the fourth theory, some hyper-technical useless topic. So then when he applied for jobs, he only applied for philosophy jobs. So a lot of people have, like me, I think, have a certain idea in mind what they want to do, but they're not correctly told about what that gets classified as in the academic hierarchy. So, I was lucky enough to have interesting questions to work on about dark energy and symmetries and things like that, so I could make a career as a good old ordinary physicist, and really start doing the philosophy part in earnest only later when I was a faculty member.
And how do you feel like in Caltech, being a small, very technical school? Are you sort of like the only one thinking about these questions? Are you isolated, or how do you feel with the community here?
I'm not the only one, but it's a small number. In fact, there is a philosophy department at Caltech, and I would say there's actually 3 faculty members here, Charles Siebens, Christoph Hitchcock, and Frederick Engelhardt, all of whom are very interested in physics. Chip Siebens is a collaborator of mine. We wrote a paper together on the many worlds interpretation of quantum mechanics. And these days, what he's primarily studying is the relationship between quantum field theory and classical physics, how you sort of get classical notions out of quantum field theory. So, they can push around the equations as well as anyone. But it is a small group, and the other 2 professors are less interested in physics as such. The physicists at Caltech, bless their hearts, have zero interest in philosophy, really. But they're an extraordinary research because they're just so good at physics, especially and notably in what you might call the foundations of quantum mechanics, right? Quantum information theory, quantum computing, things like that. So you can definitely find people to talk to at Caltech.
Is there dialogue between those 2 disciplines? Like, do the professors find each other in the halls and start talking about the origins of the universe?
No, the dialogue is me. I'm the only person who talks to both of those groups, roughly speaking. I think that Chip Siebens will as he's a young assistant professor, and I think over time he will also be a bridge between those 2 groups. But it really is a feature of academia that what you count as an interesting question is very, very different depending on what department you're in. I had the crazy idea at one point that there should be a department, there should be a university that had no departments, right? Because in a lot of ways, the existence of departments forces academics to sort of fit into some mold. And then if you leave that mold, we don't know what to do with you. And it's not just philosophy. I've been on hiring committees in the physics department where they want to hire a biophysicist, and they're like, well, is this person really a physicist? And I had to argue, well, who cares if they're really a physicist? What we care about is the work good. And I'm sure the same thing is true if someone does, economic history. Are they in the history department or the economics department, right? And in many ways, departments have a very good purpose. They give you some coherence and some colleagues to talk to. But in terms of, enforcing arbitrary disciplinary boundaries, they really hold back the academic project in very noticeable ways.
That sounds like an amazing idea. How would that work? Would it be like a university that works like oriented towards a project?
Well, I think what you could do is just have, there's 2 things that departments do that is very important. Number 1, they hire new faculty members, right? Yeah. That's maybe the most important thing a department does. It's self-sustaining. When it's interesting. If you want to know why a certain physics department hired a new physicist, almost all the decision-making power is in the hands of the faculty members of that physics department. There are deans and provosts and the president of the university, and they have to approve it, but they generally do. And they don't suggest anybody. The faculty would be outraged. It's really departments that have that power. And the other thing they do is they educate the students, right? They decide what courses to teach. They advise graduate students. They grant PhDs. For everything else, for having laboratories, for all that stuff, you could do it university-wide. You don't need really departments at all. So what you would have to do is replace those two functions, hiring new faculty members and advising and teaching students, in a more flexible way. So in the perfect world, every time you wanted to hire a new faculty member or advise a new student, there'd be a committee of existing faculty members who would talk to that person and to each other and get the job done in a way that was flexible and, made sure that students didn't slack off or anything, but also let them find their own way in what they wanted to do.
I gotta be honest, I've never been to a university, but from the outside, I get this perspective that there's like two main tasks. Well, not tasks, but like purposes that it serves. It is educating people and creating like new ideas. Do you feel like these two areas of human activity could be like done through different sorts of institutions, or does it serve a purpose that it happens in the university, both of them?
Well, I mean, that's a really, really good question, because on the one hand, it's extremely helpful that universities are institutions that both do research and teach students, because it means that what we're teaching the students is informed by what is going on at the very highest levels of human thought and activity. The real experts in the world are doing this. On the other hand, it means that when you think about what we call major research universities, okay, Caltech, Harvard, Princeton, but also, big public universities, Berkeley or University of Texas or whatever, teaching students is not why they're there. You don't get hired at Harvard as a faculty member because you're good at teaching students. That literally never happens. Yeah. You get hired because you're good at doing research, and you could be a terrible teacher and still get tenure at Harvard or Caltech or Princeton or whatever. Now, it might help you a little bit so if you're good at teaching, and certainly there are people who are brilliant teachers who are hired by the system, but it's by accident. It's not on purpose. And so there are, smaller universities, liberal arts colleges and so forth that are focused on teaching, but even they want the faculty to do a little bit of research. So it's both a good thing, but something that causes a little bit of tension, I would say.
What I love about this idea of departmentless university is the dialogue between the different disciplines. I remember clearly one of your Great Courses Plus lectures about the subject of time. It started with this idea that physicists don't really care if it makes sense to us, our best understanding of time, but we have like this urge, like this need of a narrative that makes sense to us. And I don't know. I think that's like one of the things, the great things that you bring to the table. But does science have what you would call it? Does science have like a responsibility to make sense?
Oh, I certainly think that science has a responsibility to make sense, in the sense that science describes the world, right? And the world makes sense. It depends what you mean by make sense. If what you mean by make sense is be intrinsically coherent, right? Be logical and consistent, then it has to do that because it's describing something that actually happened. It can't violate the rules of logic or something like that. But science, understanding science, learning about it as human beings, it doesn't need to seem to make sense. In other words, what we learn about the world might be incredibly surprising and counterintuitive and against everything we suspected. And that's our fault. That's not science's fault or the world's fault. That's a lesson to us that we need to update the way we think about the world. So I do think that, there's a lot of aspects of science that we take for granted. It's done by human beings. Human beings decide what questions are interesting, what questions are not interesting. They decide what papers to cite, what other people to read, who to invite to conferences, who to hire, who to give prizes to. It's a very, very human endeavor. And also, when even though it's very important to get other people who are not scientists excited about science, in exactly the same way, the world's best scientist need not be the world's best teacher. The world's best scientist need not be the world's best promoter of science or, communicator of science. Maybe they are just by accident, but it's not always the case. And so what I think is the best thing to do, and it's not what we do always, is to have a very rich ecosystem where there's lots of different kinds of people who serve the cause of science in different ways. Some will do laboratory work, some will do esoteric calculations, some will write books and give talks, some will think about the history or sociology or philosophy of science, some will draw connections between science and literature and art or other areas of human endeavor, and we should value all of these things in different ways. And we don't. There's certain things that we value, especially, I love Caltech, but Caltech is the paradigm for having a narrow view of what counts as good science, right? Building experiments, discovering things, winning Nobel Prizes. That's what makes good science.
I think that's the... sorry, go on.
I was going to say, speaking of what the people think is interesting to think about and talk about, this what you're saying reminds me of this quote that you write in your book early, God is dead. And I am really curious of what that means to you and how you came to this realization.
About God not existing?
Yeah, God is dead, this notion that we have the responsibility to understand and interpret the universe.
Yeah, this is another very good question because it's an interesting situation, once again, where if you go into a typical physics department, okay, they're trying to understand the basic laws of nature, right? How the universe works and things like that. Nobody's talking about God. Almost nobody, right? You talk to 100 physicists and maybe you meet one eccentric person who talks about God all the time. I know some people like this, some of my best friends, very, very charming, wonderful people. But most of the time when you're thinking about, the origin of the universe, the nature of space and time, God just does not enter the equation. And 500 years ago, it would not have been like that, right? I mean, the role of God in understanding the laws of physics and the origin of the universe and so forth, and the role of human beings in the cosmos would have been front and center everywhere. So it's undoubted that something has changed. And yet, most scientists are reluctant to talk about it, okay? So even though most scientists don't invoke God in their work or anything like that, they don't go so far then as to say, by thinking about science, I come to the conclusion that the world is purely natural. It's just obeying the laws of nature. It doesn't need outside creator or guidance to bring it into existence. Therefore, I don't think that God exists. So that's a little bit weird to me. So something I've said to my friends before is, those of us who think about either physics or philosophy, the fundamental laws of nature, right? What happened at the Big Bang? What are the particles and forces making us up, okay? What we do for a living basically has zero impact on people's daily lives, okay? We're not going to discover something that's going to lead to a better smartphone or change the economy or cure cancer or anything like that, okay? We do it. That's not to say that what we do is not important or interesting. It's interesting because we are interested in it, because we want to know the answers. That's enough rationale right there. You don't need to cure cancer. Finding out the secrets of the universe is interesting. Except there's one area where what we do has a huge impact on the lives of everyday people, namely that we don't need God. And most people believe in the existence of God. So whether or not other people agree with us, and not even all scientists agree with each other, but I think it's kind of our duty to at least explain ourselves, explain why we come to this conclusion and why we think this way. And almost no one is interested in doing it.
I think this...
Go ahead.
I was going to say that I think this is a great segue to another quote of your book that I really like, that says, the universe is made of stories, not atoms. Could you talk a little bit about what that means?
Sure. This is a quote from Muriel Rukeyser, who was a poet, very, very good poet. I encourage you to read her poetry, but she had this eccentric interest in science. She actually wrote the best biography of Josiah Willard Gibbs, of the Gibbs distribution, famous statistical mechanic, one of the very first great American physicists, honestly. But she also has this quote, the world is made of stories, not of atoms. And so my point in saying that she loves physics and wrote this biography is she knew perfectly well that the world is made of atoms, right? So she's not denying the scientific point of view, but what she's pointing out, in my interpretation of it anyway, is when you talk about the world, when you explain the world to somebody, let's say that you go on a date, right? You meet somebody, you're attracted to them, you go on a date, you go to a restaurant, you're talking about each other, and they say, tell me about yourself, okay? What are you going to say? You're not going to list all of your atoms. In principle, listing all of your atoms would give you all the information they need, right, to learn about you. But what you're going to do is tell a story. Who you are, what you do, what you like, what your interests are, where you came from, where you hope to go. That's the way that we conceptualize the world. We know that the atoms are out there. But when I say, like, what's in my office, I say, well, there's a table and a chair and some lamps and things like that. That's telling a story. That is telling this very high-level abstract version of what's going on in the room. And so it's really those stories that give us a handle on what's going on in the universe.
Yeah, so talking about your book, we have been reading the big picture. It's absolutely mind-blowing. I wanted to ask you, how can I explain to my mom or my grandma what's poetic naturalism?
Well, you could just buy them copies of the book for presents, right? I mean, that's the first thing that you could do.
Is it available in Spanish?
Yeah, well, I don't even know if it is. I think some of my books are in Spanish, but I'm not sure whether that one is. So there's just two words, poetic and naturalism, right? And so I explain naturalism first. Naturalism is the idea that there's only one reality. There's the world, the natural world, the universe, whatever you want to call it. It's the stuff that we study by doing science, right? By using the methods of empirical observation. We think that it obeys laws, the laws of nature. And really, when you're saying that you're a naturalist, you're comparing yourself to people who are not naturalists, who believe there is more than one world. There is a spiritual world or a theological world or something other than just stuff, okay? And you don't even need to be religious to be a non-naturalist. There are plenty of people who think that God doesn't exist, but that you need something not physical in order to account for consciousness or something like that. So you could be a non-naturalist in that way as well. You could be what is called a substance dualist, to give the philosophical lingo to it. So a naturalist just thinks there's just the world, there's just stuff. And then poetic means that there are many ways of talking about the world. It's exactly what we were just talking about. There's this sort of hyper fine-grained microscopic way of talking about the world, the fundamental level, where it's all quantum mechanics and particles and forces and space-time and whatever. But then there's all sorts of other ways of talking about it. Some of those ways are also just scientific. If you talk about biology or whatever, it's still scientific. It's still fixed by the data, but you don't talk about individual atoms and molecules. Other ways of talking about the world aren't even fixed by the data. They don't come down to science. And those are ways that involve what philosophers again would call normative ways of talking about the world, ways that judge the world as good or bad, ugly or beautiful, right? Purpose and meaning and things like that. These are attributes that we assign to different aspects of the world, but different people might legitimately do it differently. If I say that chocolate ice cream is the best and you say vanilla ice cream is the best, neither one of us is making a mistake in the same way we would if one of us said the universe is expanding and the other one said the universe is contracting, right? There's no experiment you can do to rule that out, but it's still a perfectly valid way of talking. So the poetic naturalist says there are many ways of talking about the world. All of them capture an element of reality, but it's still one world underneath it all.
I have a question related to that. So how do you come up with this idea? What were your influences? And coming back to what you were saying before, it makes me think that maybe you felt the need to explain this because many people in science departments are very narrow-minded and maybe they want to be pure naturalists and think that there's only one language, the language of atoms, and then there could be people on the other end of the spectrum. So I'm curious about that.
No, I think that's exactly right. I thought of myself as sort of being in between two different sides. And honestly, it's not even, the physicists, my fellow physicists in my physics department who I was arguing against on one side, because they just don't care, right? I mean, they're just happy to do physics. Like if you say, well, what is good and bad, right and wrong? Like, wait, whatever, like leave me alone. I got some equations to solve or some experiment to do. But there are other people who think that we can solve questions of right and wrong just by doing science, right? And I think that's just a philosophical mistake to think that. It's an inability, it's a mistake because it doesn't recognize the fundamental difference of those kinds of questions. I think that your moral or aesthetic attitudes or your location of purpose and meaning in the world has to be compatible with our scientific understanding, but it's not determined by it. And then on the other side of things, there are people who think that they're not naturalists, right? So there are people who are not naturalists. They think there are spirits or essences that you need to explain the world that go beyond the natural world. And there are other people who are anti-poetic naturalists who think that everything is just determined by the laws of physics. And so I was trying to be in between, and also I was trying to sketch out how the whole thing fits together. So there's not just physics in the book. In fact, there's not even that much physics in the book. There's some, but there's a lot of philosophy, a lot of biology, neuroscience, and just discussing about what it means to be human in the world.
So Sean, I am afraid I have a weird question, and it is: you ever read the Tao Te Ching?
I've read little tiny bits of it, but not that much. I own it. It's sitting on my bookshelf there.
Because at the very first, it says that it tries to speak about the universe. It's like, and at the very first sentence, it says that the Tao that can be spoken is not the real Tao. And it makes me think about your description of how every time we try to speak about the fundamental level of reality, it kind of like escapes meaning. And we have to create these new layers of meaning to talk about different scales of reality. That's why I love this term so much, poetic naturalism, because it seems like the more we are relating to our everyday experience, the more we are talking into like metaphor.
No, I think that there's absolutely something to that. And, there have been Western philosophers who said similar things. Wittgenstein very famously said things along those lines. But I do think that this attitude is most prominent in Eastern philosophies, not just Taoism, but also Buddhists. Buddhists are like Christians. They have all sorts of little sects, that don't agree with each other. But there are kinds of Buddhists who say things about, sort of what Western philosopher labeled monism, right? That there is only one thing, really, and you can call it the Tao, or you can call it the universe or reality or whatever. And I think the point that you're getting at, where I would agree with it, is there is a sense in which all we can do is say, there it is, and not actually talk about it in any meaningful way. And let me give an analogy which is not very good, but it gets in the same direction. Let's imagine you believed in superstring theory. Okay, so there are people who think that little particles like electrons or photons or whatever are really little vibrating loops of string. All right, and they may or may not be right, but let's say that you were along that line and someone said to you, well, but what is the string? What is it made of? And at the end of the day, you have to say, well, it's just this string stuff. That's what it is. It's the stuff out of which everything else is made. I would do the same sort of move, but for the quantum mechanical wave function of the universe rather than string theory or something like that. So when we do talk about, even just using the word string is a metaphor right there, right? It's not literally a string like that you tie things with. So yeah, I mean, other than the world itself existing, you can say that, but it doesn't really tell you that much. You just have to accept that it's there and then describe aspects of it. That's what we can use words for.
So what is right now our best description of the fundamental level of reality?
To me, as I just hinted at, it is a quantum mechanical wave function. So So this is very unfair because you just pointed out that I can't talk about it. Now you want me to talk about it. I mean, you should notice that you've just put me in an impossible spot. So that's okay. I will say words and they won't mean anything, but that's legitimated by what I just said. So when we do classical mechanics, give me a couple minutes to get there.
Okay.
When we do classical mechanics, when we talk about, the motion of the planets in the solar system, okay, or a rocket flying, or, a soccer ball being kicked, we talk about its position and its velocity, and you can do that for individual atoms or for balls or planets or whatever. And then you can say exactly what's going on. But In quantum mechanics, which came about in the early 20th century, the story is quite different. We don't talk about the position or the speed of a particle or a planet for that matter. We have what is called a wave function. And a wave function is an abstract mathematical thing. We know what to do with the wave function. The wave function tells us the probability of observing different aspects of the system. So you might not be able to say the electron is located here or located there, but the wave function lets you say the probability you will see it here or you will see it there, okay? Now, even though everyone agrees on that, people in quantum mechanics don't agree on the fundamental nature of reality. For my perspective, I wrote a whole nother book on this. From my perspective, that wave function is a direct representation of reality. There's nothing there in addition. It's not just talking about our ignorance of the world. It really is the world. And mathematically, a guy named John von Neumann back in the 1930s pointed out that these wave functions live in a vector space. So what that means is, if you think about vectors, you've all seen little arrows, right, that represent vectors, like an electric field filling space or something like that. And these arrows, they can point in three different directions, right? Up, down, left, right, forward, backward. That's because the space we live in is three-dimensional. We're very comfortable with vectors in 2 dimensions or 3 dimensions. Von Neumann is saying that the quantum mechanical wave function is a vector, but not in space, in some completely abstract mathematical space that is potentially infinite dimensional, okay? So if you want the short answer to your question, what is the fundamental nature of reality? It is a vector in a probably infinite dimensional vector space.
Whoa. So that's why we have layers of meaning.
That brings me to one of my questions that I had while I was reading the book. So at the very fundamental level, as you just described beautifully, we have this abstract mathematical description of reality. And then poetic naturalism allows us to just speak of different levels of reality, and maybe just one way, like you cannot infer what is above infer what is below from the higher description. But all of these are like mathematically described with math. And when you talk about morality, when you talk about even consciousness, does that mean that given that our most fundamental understanding of reality is based on mathematical patterns, there should be a mathematical description of these higher abstract levels, and we haven't just found it, or I'm just lost in?
No, I think you're exactly right. But what we have to be careful about is what is implied by the idea that there is a mathematical description of something, okay? The thing that makes physics interesting, maybe what you're thinking of in the back of your mind, for the non-physicists out there is a very famous paper written by Eugene Wigner, who was a Nobel Prize-winning mathematical physicist. And the paper was titled "The Unreasonable Effectiveness of Mathematics in Physics." And he was pointing to the fact that when we do physics, right, whether it's Isaac Newton or Maxwell or Einstein or whoever, we always seem to require these high-level, often brand-new mathematical concepts, calculus, vectors, tensors, complex numbers, whatever, okay? And these tools are incredibly useful in describing physical reality. But I don't think that's unreasonable at all. What I think is that no matter what the physical world would have been like, we would have described it mathematically. It's just that the mathematics may have been much uglier than what we actually have. The thing that is surprising is not that math is effective in describing physics, is that the math is so simple and pretty and elegant, right? And you can make such precise statements. When it comes to something like politics or economics, you can describe things mathematically. They're just not very accurate, right? You can say, what is the probability of someone winning an election? Or if I raise interest rates by a certain amount, how will that affect employment, okay? And I can't predict it exactly, but I predict it with certain error bars using a probability distribution and so forth. So I think that whenever you have a good theory of anything, you can make it look mathematical. The difference between physics and politics isn't that one is mathematical and one is not. It's that one is understood now pretty well, and the other is still a long way to go.
Oh, that's great. That's a great answer. So coming back, so you say in your book you don't have that much physics, but there's one bold claim in the book about physics, which is that the physical reality, or the most fundamental level that describes our reality that concerns us, our everyday life, it's complete. Like we're done. Like let's just go home, and only black holes and only serious things like that are left. So could you elaborate on that and tell the audience?
I can, but it's so the claim is very, very specific, and so I need to get it exactly right because it's easy to understand. You know, like we've been talking about, there are these different levels of description, and one level is the level of particles and forces of which you and I are made. Okay, and I extend that to the regime of everyday life. So it's not just you and me; it's the desks in front of us, the chairs we're sitting on, the computers we're talking in, and also the sun, the moon, and the stars, right? The things we literally see out there in the universe with our telescopes, okay? We have a theory that purports to describe everything in that regime. You know, everything an electron, you know, there are electrons in our brains. We have, as well as other particles, we have an equation that describes how those electrons move around, okay? And this equation has been given the name by Frank Wilczek, another Nobel Prize-winning physicist. He calls it the core theory. Gravity, electromagnetism, the nuclear forces, the Higgs boson, stuff like that, okay? And so here's the claim that I want to make. The core theory is a way of talking about everything that happens in everyday life. That includes you and me, and again, the sun and the moon and the stars. In other words, there is no extra stuff out there, okay? There's no new particles or new forces or new phenomena that actually have an effect on our everyday lives. Number two, we have no good understanding of the levels above it, okay? So it doesn't mean that we've solved chemistry just because we understand the core theory. And number three, there's no claims being made about the levels below it either. So the core theory is probably not fundamental in some real sense. It's not necessarily the final answer to anything. In fact, it certainly doesn't describe things like black holes and the Big Bang, dark matter, stuff like that, okay? But these things also don't affect our everyday lives. So it's completely possible that there's a whole layer underneath. In fact, I think, let me see, right around here, I'm actually writing a paper on this right now. Oh, yes. I have a plot. I will show you a plot of what I mean. Here's the plot. Can you see it? No, because I'm showing on Zoom. It's giving me the... but I can do this. This is worth doing. This is kind of fun. So this is what I mean when I say that some of these layers are understood and not. So the layer in blue, is it focused?
Maybe.
More or less. I think that's good, yeah.
So basically, I can describe the picture in words. So these layers from top to bottom are on top, like the macroscopic world, right? You know, giraffes and elephants and economies and the universe. In the middle layer, the blue box is the core theory, okay? So it's what we're made of, all those electrons and protons. The box next to it is new particles and forces, like whether it's dark matter or new forces of nature that we don't know about. It's completely possible that stuff exists, but we don't depend on it. Our everyday lives do not depend on it. And finally, below that, there's a layer, and the layer below it is who knows what. It's, you know, the fundamental theory of everything that we don't have yet. And the point being that the core theory might depend on that, but our everyday life only depends on that through the core theory. So in other words, whatever new phenomena there are at the very bottom-most level of reality, they might exist, but we don't need to know them to understand the particles and forces out of which you and I are made.
This is so cool. Here comes another weird question. You ever read Jean-Jacques Lacan?
Sorry, say it again?
You ever read Jean-Jacques Lacan, the French philosopher?
I have not read him. I have a good friend who I'm thinking of getting on the podcast, who's one of the world's experts in Lacanian theory, but I have not read him myself.
Because your diagram looks so much like Lacanian theory on reality versus the real. because he talks about reality like something we do out of, we create out of the symbolic and the imaginary, like basically images and symbols. And we create that so we can have like some interpretation of deep real, the real, which he calls the real, which eludes meaning, which I don't know, and it even looks like the same, you know. Instead of the real, there is like the theory of everything, and instead of I don't know. Do you think we need these these interpretations of reality because deep down reality eludes meaning?
Actually, no, I wouldn't go quite that far. I mean, I'm willing to say that reality might elude our ability to talk about it in the language that we already know about, right? To convert it into sensible words in natural language, whether it's English or Espanol or anything else.
Yeah.
But I do think that reality is ultimately intelligible. It is possible to understand what reality really is. Another footnote here, there are questions that it is very natural to ask about reality that might not have answers, not because we don't know what they are, but just because they don't apply, right? So the most obvious example of this is, why does the universe exist at all? And my answer is, there's no reason for a question like that to have an answer. Maybe there is an answer, maybe we'll find it someday, but the answer might just be, it just does. You know, there's no further answer, because the universe is unique. It's the only thing that is the universe. It's the only thing that is the totality of everything that exists. So the fact that things within the universe have explanations for why they exist does not imply that the universe has such an explanation. And our everyday intuitions might just get it wrong when they say, well, this has to be true about the universe. We should be very open-minded, not only about what the universe is, but even about what we are allowed to ask about the universe.
Along those lines, that reminds me of this part in your book where you say that we want to find causes for everything, and that's how the Aristotelian logic work, but that we don't necessarily need to have a cause for everything. And I can see like religious people or certain sectors of the population which are more on the poetic side than the naturalist side that would say like, how is that even possible? Like, how can you make an argument for a reality where there are some things that you cannot explain and you're happy with that as a physicist? Like, how would you respond to those people? Or do you see that controversy?
Oh, no, absolutely. I mean, this is a very, very important issue here, because there's this feeling that I think we should have gotten over and we haven't, that conflates or confuses the idea of causes and effects, reasons why things happen, okay, with the idea of structure and organization. In other words, there's a feeling that if there's not an effect for every cause and vice versa, then anything goes. Then it's just chaos loosed upon the world, and you can't explain anything. And my point is, no, there is actually a middle ground there also. And by the way, I don't want to fetishize being in the middle ground. Sometimes being extremist is the right thing to do. But for these particular questions, it is possible that the way the world works at the deepest level is not a story of here's a cause and there's an effect, and that's the cause of another effect, and that's the cause of another effect. But there can be another way in which the world is organized, which is just there's a pattern. And the pattern might go both ways. The example I use, and I think it's brilliant, but no one else seems to be impressed by it, just think of the integers. Think of the whole numbers, positive and negative, right? 0, 1, 2, 3, 4, -1, -2, -3, -4, okay? There's clearly a pattern. You know, if I tell you here's the number 7, you know the number before was 6, the number after is 8, okay? But you wouldn't say, 8 is caused by 7. It's not that kind of relationship between them. So there is a rule, there's a pattern, there's a rigid structure going on, but that rule does not take the form of a cause and effect web. And so that is my point about the fundamental nature of reality, that if you ask, why are my keys in my pocket rather than on the desk, that's the kind of question that has an answer. There's some reason why that is true, but you can't just take that linguistic construction. Why are my keys here rather than there? And apply it to the universe as a whole. That's a mistake, a mistaken extrapolation of what you're allowed to say using these words.
What are we allowed to extrapolate from the thing that you told us that, the description of our reality is complete? What does that imply about souls, consciousness, free will? Like, I don't know, there are so many.
Yeah. It implies that whatever that stuff is, it had better be compatible with the idea that you and I are made of particles and forces obeying the rules of the core theory. So what I say in the book is there's a whole bunch of ideas that are incompatible with that understanding. Astrology is incompatible with that understanding. Sorry, no one ever said science was pretty. It's not going to make you necessarily happy, but the constellation that Saturn was in the moment you were born has no effect on your life. There's no way that it can influence your life because we know what particles and forces could possibly do it, and they're not up to the task. You cannot bend spoons with your mind.
No.
Okay, I mean, except by telling your mind to put your other hand in there and bending it. But you cannot exert a force using what's in your mind because the core theory doesn't allow it. And also, as you say, there's no life after death. The way that we are a person, the person who we are, importantly involves information that is stored in your brain and in your body in the arrangement of atoms. Okay, and number one, when you die, that arrangement of atoms begins to degrade. It's no longer preserved over time. And number two, there's nowhere else for that information to go. So it's not a proof that there's no life after death, because there's no proof for something like that. There's just, is it reasonable or is it unreasonable? The argument is simply that if you want to believe in life after death, then you have to believe that the laws of physics as we currently understand them are wrong in some really important, noticeable way. So to me, the burden of proof is on the people who want to change the existing laws of physics. Tell me how to change them. Tell me where the equations are wrong, and then I will start taking you seriously.
One of the ideas that I found most fascinating in your book is this idea of Laplace's demon. So you say that one of Laplace's greatest contributions to humanity was perhaps a philosophical one, in the sense that he understood and pointed out that the state of the universe now, in a moment from now, depends on the state of the universe now.
Right.
Could you talk a little bit more about that and how that relates to these notions, in particular the notion of free will?
Yeah, sure. It's the most important role that plays in my book is a contrast with that way of thinking versus the pre-existing way of thinking that was handed down by Aristotle and their friends. And by the way, I love Aristotle. He was a genius. He was probably, the most influential person over a wide variety of fields that ever existed, honestly. Like, he wrote books about how to write a good play, okay, as well as books about metaphysics and ethics and physics and biology and things like that. So those were the days back then when you could do that. So the reason why we constantly refer to Aristotle and say that he was wrong is because it's always in contrast with Aristotle that we think about ourselves. And he had this idea that objects had natures, that they existed for certain reasons, that there was a final cause, the purpose to which certain objects existed, okay? And so we could think in some sense about why motions happened in certain ways or other kinds of changes happened in physical or biological systems by reference to their future goals, right? That's what it means to be teleological. The telos in Greek was the goal that you had in the future. And Isaac Newton and Galileo, a couple years before him, kind of overthrew that. They had a different way of thinking about physics, but they didn't appreciate how important it was. It wasn't until Laplace, over 100 years after Newton, who really pointed out an implication of the Newtonian worldview, which is that what happens at the next moment of time only depends on the situation of the world now. It does not depend on any future goals in any way at all. In principle, if you knew exactly what was going on in the world right now, everywhere in the universe, and you had infinite calculational power, you could say exactly what would happen at every moment in the future, and you could say what did happen at every moment in the past, okay, according to the rules of classical mechanics. And so this is now a deterministic universe. And does it have an effect on free will? Well, yes and no, because it depends on what you mean by free will. And honestly, I don't like to talk about free will because no one agrees on what you mean by it. So what it means is you can't violate the laws of physics. It means that there's a certain very strong version of free will that is ruled out by physics, what is sometimes called libertarian free will, the idea that a human being is an agent, a law unto themselves, as Immanuel Kant put it, that they are not just the sum of a bunch of particles and forces obeying the equation of the core theory. That's right out. Even once you have quantum mechanics and determinism is less obvious, this sort of a person can overcome the laws of physics just through their willpower is, whether it's true or not, it's certainly incompatible with our best scientific understanding of the world. But there's another level of sophistication where you say, okay, I get that, but is it still okay as a poetic naturalist? You know, there's many ways of talking about the world. Is there a way of talking about the world in which human beings are agents that can make choices? Even though, ultimately, if we knew what all their atoms were doing, we could predict what they would do next. And to me, the answer is obviously yes. And it's so obviously yes that even the people who say it's no are constantly talking about people making choices. They're constantly making choices themselves. They're constantly trying to persuade people to choose things in certain ways. You can't talk about human beings if you pretend that they're not able to make choices. It's certainly not a useful way of talking about human beings. So this is what is called the compatibilist attitude toward free will, where on the one hand, you might have some impersonal underlying laws of physics that has no reference to free will whatsoever, but at some higher level, at some emergent level of macroscopic personhood, it's still perfectly okay to talk about people making choices.
So how does a conscious mind emerges from this deterministic universe made out of particles and forces?
I don't know. If I knew that, I'd be rich. But it's a good question. I don't want to downplay it because that's a lot of, the purpose of me writing The Big Picture was exactly that question, because I don't talk about consciousness. I don't talk about the details about what consciousness is, because I am not trying to say, here we are, we're almost there, understanding what consciousness is. I know that, Daniel Dennett and Steven Pinker and other people have written books that basically say, a few I's dotted, a few T's crossed, we'll be there any moment. We basically understand how consciousness works. I don't pretend to understand how consciousness works. But nevertheless, I think that when we do understand how consciousness works, it will be a purely physical way of thinking about consciousness. It will not need to invoke anything beyond the physical world. So that's the case I wanted to make in the book. So my point is that even though we don't understand consciousness, that's no reason to think that we need to change the laws of physics. Indeed, if we didn't know what we knew, right? Like if you knew what the laws of physics were, but you didn't know what human beings understood about the laws of physics, what would you say is the last thing they would understand about the universe? And you might say consciousness, because the human brain is just an enormously complex system. It's sort of self-reflective, right? There's recursion. We think about ourselves. We're self-aware. It's enormously complicated, 85 billion neurons and countless many more connections between those neurons. And the neurons are different in different ways. And so it's just, of course, a system that is going to be very, very difficult to understand. The fact that we don't understand it yet is the least surprising thing in the world. And I would argue that it's zero reason to worry that it won't eventually be understood.
I'm having this thought. I don't know if it's like a hippie nonsense, but I'm just finding it very intriguing that, if reality at the most fundamental level is just these patterns that we can describe this math, and then these patterns just start congregating or making more and more complex stuff to the point that they create us so that we can write the patterns back. So there's this recursion that I find pretty mysterious. I don't know how to think about that.
Well, yeah, so that's one of the reasons why in the book, what I do, even though I don't try to understand and account for consciousness in any detailed way, what I do is sort of sketch out how little things can build on each other in a way that you say, oh, okay, like if this builds to that and that builds to that, then I can kind of see how if this happens a lot, I would eventually get to a conscious creature. Like the origin of life is something we don't understand, right? I mean, life is easier to try to explain than consciousness, but still very, very hard. If we can't understand the origin of a single living microorganism, then maybe we shouldn't be surprised, again, that we don't understand consciousness arising in the human brain. But there are little steps along the way. In the book, I talk about an idea from Malcolm McIver, who I also had on the podcast, where he says, you know, the first fish who climbed out onto land, their brains changed and their anatomies changed, obviously, because they had to breathe and so forth, but not just the breathing apparatus and the walking apparatus, the sensory apparatus changes in an important way. And his theory is, and you can sort of test the theory in different ways, his theory is that when you're underwater, water has an attenuation length. It's hard to see very far away. Even in crystal clear water, you can see meters ahead. You cannot see kilometers away, okay? And you're swimming along at meters per second. So underwater, all of the evolutionary pressure is, as soon as you see something, react to it right away. You don't have time to contemplate what to do. The reaction times need to be short. Whereas once you climb onto land, essentially you can see forever, right? You can see infinitely far away, or at least you can see things coming very, very far away, long enough that a new avenue of cognition opens up. One in which you imagine, you sit back and don't react right away. You say, well, what if I climb up the tree? Or what if I retreat back into the cave or hide behind the rock or just run away or approach it or whatever, right? So there's an evolutionary pressure that only exists once you climb onto land that gives you the ability to imagine future events. And then you can say, well, where does that ability come from? Is it just magic? And the answer is no. The answer is people have done experiments by putting human beings in, you know, fMRI machines, brain scanners. And when you're imagining hypothetical future scenarios, the blood in your brain rushes to the same area that it does when you're remembering the past. So this happens in evolution over and over again, where we get some particular ability for some reason, and then evolution repurposes the same machinery for a completely different reason, because we're not teleological, because evolution does not work by planning for the future. It takes what's already there and puts it to use again. So our imagination is just a repurposing of the same hardware that we use to remember the past. And having memory is another important question you might wonder about, and where did that come from? But it's kind of not that hard. And then the story convinces you, well, maybe it's not that hard to hypothetically imagine the future and put ourselves in it. And you can kind of see how that would be the first step to being a self-aware, conscious creature. It's not the only one. There'd be 100 other steps along the way, but by breaking it down into bite-sized problems, you might be able to make real progress.
So would you say that the more information we gather from the world, the more we are approaching to a mind similar to Laplace's demon? Meaning
No,
the more
I would never ever say that. You know, we're getting more and more information about the world, but it never has been and never will be anywhere close to Laplace's demon. So let me put it, there's one very vivid way of saying it. Roughly speaking, to have a computer big enough to understand the whole world, the whole universe, the computer would need to be as big as the whole universe. And basically it would just be a copy of the universe. That's what it would be. Laplace's demon was only ever meant to be a thought experiment, right? Even if you just say, well, I would like to understand what happens over the course of 2 seconds of time, right? I want to predict 2 seconds in the future. Well, you would need to understand what's going on in a region around you 2 light seconds in size, the distance light can travel in 2 seconds, which is from here to the moon. So you need to know every single atom, every single photon of light between the Earth and the moon, including on the Earth and on the moon, just to predict what's going to happen 2 seconds in the future. That is not a very practical future program for technological advancement.
So what is going on when we are imagining like models, imperfect models of the world, but we can make predictions from them?
Yeah, well, this is an amazing property of the world that you don't need to have all the information to make good predictions. It didn't need to be that way. This is one of the aspects that is mysterious about the physical world, is that there's some situations, very, very specific situations, in which with a very tiny fraction of all the data that's there, you can still make very, very accurate predictions. So the example I like to use is, again, the Earth moving around the sun, okay? We all know, we can predict where the Earth will be in its orbit millions of years in the future and millions of years in the past. This is what Laplace had in mind. Laplace was one of the people who really told us how to do this mathematically. But if you think about it, the Earth has something like 10 to the power 50 atoms in it, okay? And when you start talking about where the Earth is going to be, does anyone ever start listing all 10 to the 50th atoms and their positions and their velocities? No, they don't do that. What they tell you is the center of mass of the Earth and the center of mass velocity of the Earth. So really, it's literally 6 numbers. Like if you want to be very tricky about it, you could add in the rotation of the Earth or things like that. But a handful of numbers is all you need. So in principle, there's 10 to the 50th numbers, and you throw away almost all of them, left with only 6 numbers, and you can still make good predictions for what's going to happen. But the point here is you had to be very, very specific about what information you kept and what information you threw away, right? If I say, well, out of these 10 to the 50th numbers, if I just give you the velocities of all of them, well, no, let's put it the other way. If I give you the positions of everyone, but none of the velocities of those 10 to the 50th atoms. So I'm giving you half of the information, way, way more than you need, right, to predict the Earth moving around the sun. I'm giving you all the velocities, but all the positions, but none of the velocities. What can you predict about where the Earth will be later? Nothing, because you don't know what any of the velocities are. You have no idea where the Earth is going, okay? So that's the generic situation. The generic, most common, typical situation is unless you have almost all the information, you can predict nothing. It's a very special, very precious, very unusual, and very fortunate set of circumstances when you can make good predictions on the basis of small amounts of information. That's when you say you have a useful, higher level emergent description of what's going on.
That's really cool. I really wanted to ask you this. Although we know the physics that describe or relevant, everything relevant to our daily life experiences, and we know the biology that took us here. Today, society still believes in an almighty God deciding on our lives. So, how can we change that paradigm? And more importantly, do you think we need to?
Well, I wouldn't say I think we need to, but I think it would be nice. So if I'm right, I would be happier if other people agreed with me about almost everything, right? Not just the existence of God. But maybe I'm wrong about some things, so I should listen to what they have to say. And I think that, the question you're asking is an important one, but it's a difficult one because the idea of knowing the right answer is very different from the idea of convincing someone else of the right answer, especially if they're predisposed to disagree with you. That's a whole nother scientific study of psychology and persuasion and rhetoric and things like that. And I know a little bit about it, but I'm not an expert. And I think that, there's a feeling in certain circles that all we have to do is sort of shout at people and tell them facts, and eventually they will agree with us. But that's, wildly wrong as an empirical matter. It's somewhat amusing that the set of people who are most pro-science and pro-data and pro-experiment, when it comes to talking to each other, pay no attention to the data about what works and what doesn't, and so forth. So, for example, here's one example that struck me. If you want to tell somebody, the Earth really is warming because of human-induced climate change. Okay, so if you print up a poster and you say it is not true that climate change is a lie, okay, people will come away from that thinking more likely that climate change is a lie, even though your poster said it is not true that, because that's the first thing you put up there, because the human brain is just not rational in many, many ways, okay? So there are strategies for persuasion and so forth that, again, I'm not an expert in, but that's what I would want to study if that were my goal in life. The one thing that I do recommend to anyone who thinks that should try to make the world a better place by making it more rational and scientific and evidence-based is, rather than just trying to use the force of a better argument against people, be a good example. Show them that you can live a happy, successful, moral, valuable life without believing in all those things you don't believe in. Just be a role model. Don't be a jerk. Be a good person. Be someone else they want to be. And that kind of experience of seeing people who are friendly and approachable and living happy lives by believing in science and so forth is way more influential, I think, than all the facts and figures you can ever muster.
What you just said begs the question, like, do you think that's actually feasible in real life? Because sometimes I think, like, okay, I have these circumstances that allow me to have, like, to not rely on that to get on with my life. But some other people have many different tough circumstances, and that's why they seek God. So, like, knowing human nature and the challenges of real life, like, how feasible that be? It's really complicated.
Well, it's I think one of the mistakes you can make that could make you too discouraged about this when you're trying to change people's minds is there are plenty of people out there whose minds are just not going to be changed. And if you focus on them, it's very easy to get discouraged and shrug your shoulders and move on with your life. But that doesn't mean there's not a lot of other people whose minds could be changed, or even more importantly, whose minds just aren't made up yet, one way or the other, right? Clearly, people do move from one set of beliefs to another. That really does happen sometimes. Maybe not as often as we would like, but it does happen. So who are the people who are reachable, and how can you reach them? For other people, there will always be other people who you disagree with very, very deeply about something, and you're never going to change their mind. But for whatever reason, you value them, they're your family, your friends, or whatever. So then just don't talk about that thing, right? Change the subject. There's only so much. It depends on your personality and their personality. Maybe you have fun arguing over it, even though you'll never agree. My own strategy is just to talk about something a little bit less contentious. But there are plenty of people, like I've given talks to church groups, right? I've been invited to come into a church and explain to them why God doesn't exist. And roughly speaking, everyone over the age of 30 completely ignores me, but everyone between 15 and 30 at least listens. That's a generalization, but it's roughly speaking true because their minds aren't made up yet. And you can really reach people. And by the way, you can't just ask them at the end of the evening, have you changed your mind? They might not change their mind for another 10 years, but you might have planted a seed there that will eventually grow.
There's an argument for religious thinking that is that without God we couldn't have morality. How could we? I don't know. I believe this pushes us in the direction of creating a new morality from the perspective of naturalism.
Well, I think there's two separate issues here. One is, could we even imagine being moral without God telling us right and wrong? And I basically buy into how Plato undermined that argument in the Euthyphro dilemma many, many years ago, right? Like, if something is good, is it good because God said so? And if that's true, then God could say anything and it would be good, no matter how evil we thought it was. But if it's good, even if God doesn't say so, then God is not playing any role here, right? And I think that, we can make that more and less sophisticated versions of that argument. But the acid test would be, if someone really believed that they got their morality from God, to say, well, what are the things that God tells you are moral that you personally find kind of abhorrent, but you do them anyway because you know that God tells you they're moral? And the answer will always be almost nothing, right? People don't do things just because God tells them to do it. But the other half of that question that you brought up is, okay, if you don't want to offload the task of figuring out what's right and wrong onto God, where does it come from? Where does a naturalist be able to construct their ideas of right and wrong? That's actually a much harder question. That's a very contentious question. I have some opinions about where it comes from. I talk about them in the book. There's a philosophy called moral constructivism that I find is a very good way of thinking about these things. But it's you first have to get over the idea that morality is kind of like math or physics, something you can do an experiment on and get a proof or a demonstration or whatever. Morality is constructed by human beings. And once you accept that, then we can start making progress. But the gap between people who believe that morality is sort of like logic and science versus people who believe that morality is something invented by human beings is the first step in making progress there.
This is surprisingly refreshing because once we start talking about naturalism and about like a universe made only of matter and energy, one kind of loses this like metaphysical aspect of life. But once we start like identifying parts of the universe that we bring to the table, I don't know, this kind of fills me with a sense of purpose as a human being.
Well, look, I think I have this attitude that here's a very too simple, but still it gets to the right point motto here. In a world which is just obeying the laws of physics, can there be purposes or meaning? Well, I'm in the world. I obey the laws of physics, and I have purposes, and things are meaningful to me. Therefore, yes, it's just obviously true that the world can have purpose and meaning. But the difference is that the purpose and meaning are not located somewhere out there. They really do come from within inside me. And that's perfectly compatible with the idea that I am the end product of millions of years of evolution and so forth. That's fine. But here I am. I have things that I care about, things that I value. That's why I call the last section of the big picture caring, because I think that human beings caring about things, not just caring in the sense of taking care of, but being invested in, having an emotional reaction to, that's where value and meaning comes from. There's still room for moral philosophy and ethical philosophy and literary and maybe even quasi-spiritual reflection on what it all means, because that caring that we have is the starting point, but we can still think about, how to make it a little bit more systematic, internally consistent, make it make sense, maybe even learn new things, realize we should have been moral in a different way than we had originally thought.
We just want to make sure we've been running a little bit over an hour, so I just want to ask.
I think we should wrap up soon, but I'm happy to have a couple more questions here. Yeah.
All right.
All right.
I need to know before we wrap up. Does time exist?
Yes. Look, when in my time zone, literally, again, you asked two questions in a row. One is, do we have enough time to go on? And then does time exist, right? Okay. So whenever someone says, the discussion will begin at 5 p.m. Pacific time, okay? No one ever panics. No one is ever like, what does that mean? I don't understand these words, these concepts that are being floated around here. Is this some kind of weird metaphysical idea I don't understand? Everyone uses time perfectly well. They know what it means. They operationalize it, and it's fine. So I would say that's enough. To a poetic naturalist, that means it exists. It's a really useful concept. We all share it. When I tell you that something is going to happen at 5 o'clock Pacific time, that conveys very real information into your head that otherwise would not have been there, and you can act on that information in consistent ways, okay? What it doesn't mean is that time is necessarily fundamental, right? Because I've been very open-minded about this bottom layer of understanding the world, the fundamental nature of reality, the theory of everything, whatever you want to call it. Time may or may not be part of that fundamental nature of reality. It might just be a useful approximation like the center of mass of the Earth, right? It might not be like all the individual atoms, but the center of mass of the Earth exists too. It's a real thing. It helps us calculate where the Earth is going to be. Time exists in exactly that way.
So if it's not fundamental to the basic layer of reality, where does our perception of time come from?
Well, our perception, both words, our and perception, neither one of those are part of the fundamental nature of reality, right? When you start a sentence with our perception, you're automatically talking at this much higher level of emergent, where there are human beings, us, you, me, etc. So we have human beings and we have perceptions. So there's a mind and it gathers perceptions and things like that. So the fundamental nature of reality is irrelevant to how we talk about. I mean, you have to be compatible with it, but you don't need to know what it is. Again, I know what you mean when we say we're going to start at 5 p.m., even though my knowledge of the fundamental nature of reality is completely absent, right? You could have told Aristotle you're going to start at 5 p.m. He would have understood it perfectly well too, even though he doesn't know about quantum mechanics or classical mechanics. That's the nice thing about poetic naturalism, is that the layers, the different levels of description, have a life of their own. They need to be compatible with each other, but you don't need to understand all the lower levels to use the higher levels.
So, for example, when someone is talking about quantum healing of the aura, they're kind of breaking the rules of poetic naturalism.
Yeah, because that's incompatible, right? I mean, the most blatant, obvious kind of thing is something like energy conservation, right? There's a reason why you should be skeptical if someone says they built a perpetual motion machine, because you don't need to look at their blueprints. You know they're violating the fundamental laws of physics, right? And likewise, anything that we do needs to be compatible with the core theory. That's why I can say that astrology or telekinesis are probably not real. But that restriction that we need to be compatible with the core theory still allows a tremendous amount of freedom that we don't understand. Otherwise I'd be able to predict the stock market, and I can't. So the fact that we need to obey the core theory is a very, very weak constraint on what can happen in the human scale world.
This is great. I guess some closing remarks for all of the people listening to us. Like, if they want to start thinking about these questions, maybe there's some students that haven't even chose their major. Would you say physics is the way to go? Or what would be the advice for some young minds that want to start thinking about these deep questions?
I would not say physics is the way to go. I think that everyone has different ways, or at least there are many, many different ways compatible with different people. I think that searching for truth, trying to understand how the world works, being honest with yourself, being curious, all of these are universal virtues that everyone should be able to use in some ways. But those virtues can manifest themselves in physics, in computer science, in history, in literature, in economics, or a whole bunch of different ways, or in ways that are completely non-academic, right? I mean, there are other ways of trying to understand the world. So, I think that what I tell my graduate students, graduate school, when you enter graduate school, as some of you might know, it's an important moment in your life. And for other reasons, among other reasons, it's an important moment because you are undergoing the transition from being a student to being a scientist, okay? You're becoming a little bit more independent, and it's not grades that matter anymore. It's research now and the work that you do. And so you have to choose what research to do. Even if you're in a physics department, even if you're in the theoretical particle physics group, you still need to figure out what specific research project you want to do. Likewise, if you're in economics or history or whatever. And so how do you do that? And what I tell my students is, look, there's a set of questions you can imagine asking that you personally think are fascinating and important. There's another set of questions that everyone else thinks is fascinating and important, right? The field more broadly, or academia more broadly, or the world more broadly recognizes these as fascinating and as important. Look for the intersection of those two things, right? Look for the problems that you think are fascinating, important, and the world agrees. And if the intersection is empty, then you might want to rethink where you are, because you're going to have a tough time. But don't just say, well, this is what I think is important, the world better adapt. And also don't just say, everyone else seems to think this is important, therefore I should do that, even though I think it's boring. You better be working at the intersection of those things. And I think that the same thing holds true for what field to pick more broadly, right? Pick a field that speaks to you and speaks to the rest of the world.
Beautiful, beautiful.
John, thanks so much for being here. It's been such an honor.
Yeah,
It was an amazing time. Thank you so much for sharing your insights with us.
My
Yeah.
pleasure. Very good to have for you to have me on. Hi to everyone in Mexico. I hope that before too long we'll be able to travel again, and I'll get to visit. I've only been to Mexico once in my life and not really seen much of it. But I'm a big fan of world travel, and now that we've been in lockdown for a long time, I miss it quite a bit. So I'm going to be traveling even more than usual once we all get released.
Oh, in
Let us know
Mexico.
if you need any tips.
Yeah, there's a lot of things to explore in Mexico and a lot of great
know.
natural places. Awesome. Thank you so much. Sean.
Yeah.
And I guess Pepe didn't want to look like a fan, but I gotta tell you, I'm a big fan. I've been listening to your podcast, watching your videos, reading your books, and it's just great to have you here. Thank you so much.
Yeah,
Thank you very much.
so much. And people in Mexico read Sean's book, the Big Picture, and many others that he has.
Are you working on a new book, by the way? Is there something that we should be expecting on the horizon?
I am, books take years, so nothing soon. Nothing's going to come out in 2021. Let's put it that way. But yes, books will come out. I have many books that I want to write. I gotta stay in shape and eat healthy so I can write all the books that I want to write.
Awesome.
Sean,
You do have one that recently came out, right?
My most recent book was last year, was Something Deeply Hidden, which is about quantum mechanics and the many worlds interpretation of quantum mechanics. Again, I don't know the translation status of that. Like occasionally, I don't know, I get emails saying, is it okay if we publish this in Italian or whatever? And I say yes, and then I forget. And they may or may not send me a copy of it. But yeah, that's my most recent book. And it'll be a few years before the next one comes out.
well, we were already like saying goodbye and all, but that sounds like a really good question. How does a many world interpretation work with poetic naturalism? I mean, if you have time.
Sure. It only takes 30 seconds to explain the many worlds interpretation, because I've already told you that in quantum mechanics, rather than saying that an electron is a little point with a location, it's a wave function that is spread out all over the place. And the wave function tells you the probability that if you look at it, you'll see it here or there or whatever. So you can ask yourself, if I look at it and I see it here, what happened to the rest of the wave function? If you just thought the wave function captured your knowledge, then that's not even a question. You were just wrong about all those other possibilities. But if, like me, you think the wave function is really representing physical reality, what happened to the rest of it? And the many worlds interpretation says every possible measurement outcome comes true, but in a separate copy of reality. So there's a copy where you see the electron there, a copy where you see it there, a copy where you see it there. And these are separate worlds, and they will never interact with each other again. That is what is predicted by the formalism of quantum mechanics. The only question is, can you believe it? Can you muster the courage to take that seriously?
Wow. This has been enlightening. Thank you so much.
We better read that book and maybe have you over again. That would be awesome.
That sounds good to me.
Thank you so much. Sean.
Thanks, Sean.
All righty, we all set?
Yeah, this has been perfect. Thank you so much. And let's talk again soon when we finish your new book.
Okay, that sounds very good. Thanks, guys. Thanks for having me on.
Thank you.
Thanks, Sean.
Bye-bye.
Bye.
Bye.
Ustedes estuvieron aquí. ¿Qué tal,
Fue como... ¿Nunca viste el episodio de Drake y Josh cuando se acaban de subir al demoledor? Algo así, fue como ir sobre el lomo de un tigre pasando por el ojo de un huracán o algo así.
Justo.
No, es fascinante.
Sí. ¿Les parece si leemos? No llegaron tantos super chats, pero bueno, uno dice no entiendo. Vamos a subir esta entrevista con subtítulos, no se preocupen. Tomarán por lo menos una semana, pero se subirá con subtítulos. Carolina Morales se volvió miembro, Naomi Regina también, Kingato se volvió miembro. Kingato después dice, the scheme Shin shows seems like can be doubled down as you don't need to know how a car works to drive it. ¿Pensamientos al respecto?
¿Cuál fue la primera palabra que dijiste?
The scheme, como el panorama.
Sí, el esquema.
Ajá.
Sí, exacto. O sea, creo que lo que el naturalismo poético te dice que tú sabes que la razón por la que tu coche funciona es porque existe un motor de combustión interna y tenemos las leyes de la termodinámica y demás, pero tú, o sea, esa realidad debajo no es necesaria conocerla para saber que es un objeto físico y que puedes manejarlo. Entonces creo que tiene algo de cierto ese comentario.
Ajá, es un poco como jugar fútbol, ¿no? No necesitas como saber los mecanismos que están ocurriendo dentro de ti para mover una pierna y después la otra y luego coordinarse. Es como, nada más quieres meter gol.
Exacto.
Y finalmente Javier Escobedo dice, there is no science without the mystical and vice versa. Eso hubiera sido una buena pregunta para que Sean nos dijera que no.
Sí, pues depende de qué te refieras con lo místico, ¿no?
Ajá.
O sea, hay muchas cosas en la ciencia que son místicas porque son profundamente interesantes, pero si te refieres a lo paranormal, pues no.
Sí, lo que yo he pensado mucho es como, o sea, por decir, en los temas del origen de la vida, que es lo que más me interesa, el hecho de que la vida pudiera emerger por fenómenos físicos o la conciencia o lo demás por algo que pudiéramos explicar, no lo hace menos místico y mágico, si quieres. Simplemente tenemos la capacidad racional para poder algún día explicarlo. Entonces sigue siendo algo, o sea, el universo no tuvo que ser así, ¿no? A lo mejor los patrones que había en el universo son indescifrables y no habríamos tenido ningún progreso, pero por alguna razón tenemos, como dice Sean, podemos arrojar muchísima información y quedarnos con poquito y aún así poder tener predicción y entendimiento de la realidad. Entonces eso es como místico, misterioso, o sea, no tengo que invocar a Dios o cualquier elemento religioso para decir, wow, o sea, soy parte de este universo, soy el universo descubriéndose a sí mismo, que es lo que me gusta.
En todo caso lo hace más significativo, ¿no? Porque entonces lo baja de la categoría de dogma, de algo que sabemos que es y no sabemos por qué, a algo que podemos comprobar por nuestros propios medios. Apenas ayer estaba hablando con una amiga que está aprendiendo de termodinámica y dice que cuando resolvía matrices se sentía poderosa. Entonces ese sentirse poderoso creo que nos habla de una recompensa hasta casi fisiológica al acto de comprender.
Sí, yo pienso que, o sea, para mí la actividad científica es como un paso natural después del misticismo supernatural y religión y demás. Simplemente la capacidad que el cerebro humano tiene de hacerse preguntas ya nos da esa intrínseca curiosidad que tenemos que satisfacer de alguna manera. Y mira, no sabemos hasta dónde los delfines, los pulpos, lo que quieras, el animal más inteligente que te puedas imaginar, no sabemos qué tantas preguntas se hacen, si es que se hacen preguntas. Hasta hoy en día, con bonobos o chimpancés, hemos tenido lenguaje de señas y te pueden decir quiero la banana o hoy me toca reproducirme o lo que sea, pero nunca hemos logrado que el mono te haga una pregunta. O sea, ¿tú qué pedo? Ajá. Eso nunca pasa. Entonces, yo pienso, y esto es una especulación, que cuando transicionamos a la capacidad, alguna recursión de poder pensar en nosotros mismos y preguntarnos, estas cosas tienen que emerger naturalmente. Primero, misticismo, no sé cómo funcionan las estrellas, pero me están rodeando, tengo miedo, y llega un güey que te dice que Dios existe, y luego ya empiezo a indagar con el método científico, pero ese descubrimiento mismo de la naturaleza, de los patrones que forman todo lo que nos rodea y a nosotros mismos, es igual de mágico y místico que algo que te explica sobrenaturalmente la religión.
Hasta más, ¿no?
Hasta más. Bueno, sí, ahí es mi sesgo total, pero sí, mucho más.
Pero la neta sí, este pedo fue iluminador. Siento como que muchas cosas que todavía no comprendía, como que finalmente es como, ah, claro, ahí está.
Sí, no, increíble. Qué oportunidad tuvimos, la verdad. Y ojalá que todos los que la hayan escuchado les gustara y pues a ver si hacemos otras chidas como esta.
Bueno, pues que nos echamos el otro libro, Sean.
Estaría bueno, estaría más abstractón, pero estaría interesante. A lo mejor primero un ciclo diferente y luego ya volver a ese libro. Digo, no.
Sí, estaría. Pues algo más, conclusiones.
Lean The Big Picture. No sé si está en español. ¿Ustedes saben si está en español?
Yo lo busqué, pero no.
Pero en general, para mí fue demasiado iluminador porque yo por mucho tiempo leí estos libros de Stephen Hawking y que te ofrecían la teoría del todo y siempre fue como, oh, rayos, creo que trabajo en biología, no trabajo en física, creo que no trabajo en la teoría, no estoy al alcance de escribir algo fundamental de la naturaleza. Pero Sean Carroll es muy, no solo es claro, sino es bastante... tiene completo sentido lo que dice. Tenemos simplemente distintas formas de hablar del mundo. Desde la sociología hasta arriba hasta la física de partículas. Depende qué es lo que te motiva más, qué es lo que te interesa más, de qué forma puedes contribuir tú a entender mejor el mundo. Pero no hay tal cosa como una teoría del todo o algo así, entonces todos tenemos chance de hacer algo importante. Creo que es como un alivio que a mí me dejó.
Sí, definitivamente.
Porque a un nivel básico, supongo, bueno, acá nosotros estudiamos ciencia, pero yo siento que no entendí física hasta que empecé, no solo leer el libro, pero también el podcast. Es demasiado accesible, como que cualquier otro físico te hablaría de estos conceptos de una forma completamente esotérica y te quedas pensando como esto no es para mí, y acá te lo pone al alcance de la mano como mira, tú también lo puedes entender, no es tan difícil y hablemos, y esto te puede llevar a discusiones sobre cosas que son más cotidianas y conceptos que están más al alcance. Entonces creo que es una lectura bastante fundamental.
Sí, a mí me impresiona mucho cómo puede hablar de todos esos conceptos con tanta facilidad. O sea, lo hace ver muy fácil, ¿no? Como que, Simón, ahorita te explico la función de onda del universo. Pero ya cuando tú lo intentas explicar a tu mamá, mira mamá lo que hace. Ya te quedas como, no, es fascinante.
Sigo todavía con el vértigo de la última respuesta que nos dio acerca de cómo la función de onda del universo son todos los universos posibles existiendo, pero imposibles de interactuar unos con otros, y como nos dice, pero ahí la pregunta es si tienes el valor de considerar seriamente esa idea. Es como, what? Mindblown, todavía.
Sí, les recomiendo también mucho su canal de YouTube. Tiene videos que se llaman
The Biggest
Ideas in the Universe, y habla sobre estos temas ya con más, un poquito, no te resuelve las ecuaciones, pero te escribe una función de onda y demás. Y está bastante interesante. Un comunicador, un pensador muy picudo. Qué chingón que tuvimos esta chance.
Sí. Y además de ese privilegio, creo que también es un privilegio vivir en una época en donde conocemos suficiente del universo para poder formar una filosofía construida sobre ese conocimiento. Y creo que Sean hace un muy buen trabajo explicando cuál es ese marco que podemos usar para no nada más entender el universo, sino a nosotros mismos y nuestro lugar en el universo. Así que yo creo que este conocimiento tiene un impacto tangible en nuestro comportamiento día a día y cómo nos relacionamos unos con nosotros, que para mí es bastante valioso.
Sí, como es una explicación de qué es la realidad y de dónde venimos, que es compatible completamente con lo que conocemos del mundo, y eso es completamente una lectura o algo obligado para todo el mundo. Sí.
Pues amigos,
pues muchas gracias, Pepe, por tenernos aquí.
Hombre,
ha sido un honor estar aquí contigo también.
Muchas gracias a ustedes por hacer esto posible. Estuvo muy chingón, y que se repita, ¿no?
Se repita aquí, sí.
Repita.
Bueno, amigos, ustedes estuvieron aquí. Muchas gracias por haberle caído. Estuvo muy chido. Para todos los que no entienden, vamos a mandar a traducir este video. No se preocupen, porque todo el mundo merece enterarse de estas cosas que hablamos hoy. Que tengan todos buenas noches y nos vemos en la Posada del Santo. Hasta luego.